Drawing multiple bonds in Lewis structures. Watch me work it. First, let's review the rules that we use for drawing Lewis structures. I call them Revis rules of order. If you've seen this already, you can fast forward. First, draw the individual drop dot. First, let's start with the Revis rules of order. If you've seen these rules already, you can fast forward. First, draw the individual dot structures. When you draw them, focus on the single dots to get started. Connect the single dots at obvious bonds. Make the obvious bonds the things that look like it makes sense to connect them. Combine any leftover single dots into lone pairs. Then shift lone pairs to satisfy appropriate octets. So watch me work it by doing some problems. What is the Lewis structure of CO2, first of all? So let's do the Lewis structure of CO2. So first, following rule number 1, we draw out carbon, which has 4 valence electrons. We know that carbon has 4 valence electrons because it's in 4A, therefore 4 valence electrons. So it's the central atom. We have oxygen, which has 6 valence electrons, 6 valence electrons because it's in group 6A. We draw 1, 2, 3, 4, 5, 6. I'm going to naturally group this on the other side because it just kind of looks obvious to me that this is going to be distributed about the carbon. So if I look at carbon, it has four opportunities to bond because there are 4 single dots. Oxygen has 2 opportunities to bond, and I have 2 of them, so I'm just going to do the obvious. There's 1 dot, there's 2 dots, there's 1 dot, there's 2 dots. If I do that, then I redraw these where they look really a lot nicer, neater. I didn't do anything to these lone pairs, so I leave them sitting there. Don't get fancy. I just draw it here. These lone pairs sitting there. And there you have it. That's carbon dioxide. And by the way, it does satisfy the octet rule. Look around the oxygen, there's 8, 2, 4, 6, 8. Look around the carbon, 2, 4, 6, 8. Then look around the other oxygen, 2, 4, 6, 8. This method works a lot better than pooling all the electrons, then setting the carbon out, making up a connectivity, then starting to put lines together in dots. You can lose track of your count that way. All right, so let's try another one. What is the Lewis structure now of HCN? So let's draw the valence electrons for carbon. We know that's 4 by now, right? Well, just in case you don't, it's 4 valence electrons, or you do the electronic configuration and you get the same answer. We have carbon, 4 valence electrons. We have a hydrogen with 1. Hydrogens are always peripheral atoms. They're never in the middle of anything. They're the last thing you put on the outside when you draw structures. Okay, so you hold the hydrogens to last. Next, we have nitrogen, which is 1, 2, 3, 4, 5. 5 because there are 5 valence electrons, group 5A. And so I'm going to take the obvious bond, and this wants 1, carbon wants 4, nitrogen wants 3. So I'm just going to do this. I'm going to say 1, 2, 3. Oh my goodness, can you do that? Yes, you can. You just bonded them off. So that's my initial, and then I'm left with 1 dot here and 1 dot here. I'm going to take the obvious, and there I get H, C, 1, 2, 3, N with a nitrogen lone pair left on top. But boy, I am just a stickler for symmetry. So I'm going to redraw it just so it looks a little nice and neater. But both structures are right. Actually, there's nothing wrong with this one. It's just as good as the one I just drew. Okay, so there we have it. And if we check the octet, of course, 2, 4, 6, 8 around carbon, 2, 4, 6, 8 around nitrogen. Everybody's happy. That makes for a good structure. What is the Lewis structure of H2SiO? Silicon in the middle, 1, 2, 3, so dot, 1, 2, 3, 4 dots, 4 because it's in group there, silicon right there, 4 valence electrons. So I draw that, and then I have O, which has 1, 2, 3, 4, 5, 6. And what about these other compounds? Well, if it's oxygen, it'll do the same thing for sulfur, anything, selenium. All of them in that same group will do the same thing. Silicon's like carbon and germanium. So if you know one group, you know them all. So we get this. Then what are we missing? An oxygen. Then we have two hydrogens. I'm just going to put one right here and one right here out of the way. I just like to distribute them around. So I'm going to take the obvious connections. I'm going to take this as a single dot. It looks for another single dot. It makes a sigma bond, a single bond. And this one looks for this dot and makes it. And now it makes a pi bond. This is a sigma bond. The second one coming in is a pi bond. So here we have those two dots taken care of. We have two leftover dots. Why not? Go here, make the obvious. And then I draw this, get a double bond here, here, and here. I get a single bond here and here. It fit the rules for the octet. Silicon has 8 around it. Oxygen has 2, 4, 6, 8 around it. Everyone's happy. I drew the individual dot structures. I connected the single dots. I didn't have to worry about this nor this. Worked out really nice for me. 2 rules took care of it all for the simpler structures. All right, what is the Lewis structure for HNO3 nitric acid? Let's draw nitrogen as a central atom. I'll give you that. We know it's nitrogen, most likely because it has 3 individual dots to start with. Oxygen, 1, 2, 3, 4, 5, 6. I'm just going to distribute this around because it just kind of looks like it makes sense, right? So I'm going to go 1, 2, 3, 4, 5, 6 here. And then I'm just going to put another one over here. 1, 2, 3, 4, 5, 6. I always use this pattern every time. That way it gives me an idea of what the initial connectivity might be. That's rule 1 taken care of. Rule 2, my initial connectivity of oxygen is going to be 2, 2, 2, nitrogen 3. I have a hydrogen to take care of. So let's just drop this hydrogen over here for right now. Hydrogen will always be a peripheral atom, so I always set it to the side and deal with it at the end. Okay? So ready? Well, since it's a peripheral atom, I'm going to go ahead and connect it right away to this oxygen and get it over with. It's got to be connected to oxygen. It can't be to nitrogen because nitrogen in the center and I have 3 oxygen. It just kind of makes intuitive sense. Then what I'm going to do next is I'm going to go ahead and take this leftover dot here and I'm going to connect it there. That lone dot connected there. So now all the dots on this oxygen is satisfied and the hydrogen is satisfied. Now I'm going to have to deal with this one. So I'm going to take this oxygen and I'm going to connect it here, and that takes care of it. And then I'm going to take this one and connect it here. Everybody's connected, but I noticed something here. I noticed that I have a couple of here leftover single dots. So let me tell you what you want to do. Combine your leftover single dots. So I'm going to pick this dot up and move it all the way across town to here. And I'm going to draw an initial structure and take a look at it and see what that looks like. Because now I'm down to rule number 3. Everything now is paired. So I have hydrogen, oxygen, lone pair, lone pair. I'm going to twist it around here and put it under there. Go here, nitrogen, lone pair, oxygen. This is the oxygen on the right side. And that's the one where I picked up the lone pair and brought it all the way over here. And then right here, I'm going to have oxygen. And it's going to have 2 lone pairs on it. I'm going to try to put them on the side where you can see them. And I do this. Now that's an initial structure. Not bad structure, actually. So let's check the octet rule. Hydrogen has 2. This oxygen has 2, 4, 6, 8. This nitrogen has 2, 4, 6, 8. This oxygen here on the far right, 2, 4, 6, 8. The one at the bottom has 2, 4, 6. 6. Now, oxygen would prefer not to have 6 because it's in group 16. It wants to have an octet of 8, like 17, 8, like this likes to have 8. This likes to have 8. This likes to have 8. And this is happy with 6. So I better see if I can find a way to satisfy this. Well, I can. That brings me to rule number 4. With rule number 4, I'm going to take this set of electrons and shift them down to here, both, and make a new line. Can I do that? I absolutely can. And because I didn't plan my artwork well, I'm going to, well, I'll draw it right up here at the top. Here we go. Ready? I'll have H, O, line, line. I didn't touch this, so I'm just redrawing right now. And I'm going to squeeze it in right here, O, with the dot still on it. I'll redraw the structure in a minute. And the 2, I did that. I moved those 2 down. Now I have 2, 4, 6, 8. On the left side, I'm going to redraw the entire structure so you can see it a little better. H, O, N, O. Oops, don't want to do those. Okay, let's see. I better go pick up an eraser and get rid of those. Didn't want to do those. Go back, grab my pen. There we go. So now we have 2, 4, 6, 8, double bonded O, lone pairs, lone pairs, lone pairs, lone pairs, lone pair, lone pairs. On the bottom, now we have 2, 4, 6, 8. Nitrogen has 2, 4, 6, 8. Oxygen on the right, 2, 4, 6, 8, 2, 4, 6, 8. Everybody gets a smiley face. It's very happy. So there you have it. Watch me work it, drawing multiple bonds in Lewis structures.